Here is the 6th FRQ from the 2019 BC exam. So first they want us to find the third degree Taylor polynomial for f about x equals 0. So f of 0, if you look here, they tell you that they give you a portion of the graph of f and its tangent line. And so x squared, that graph must be the function, and then x to the 1 power must be the tangent line, which makes sense because it looks like a tangent line. So f of 0 is 3. F prime of 0, it goes down 2 over 1, down 2 over 1. So f prime of 0 is negative 2. So for your third degree Taylor polynomial, you have 3 minus 2x plus, and then there's your second derivative, 3x squared over 2 factorial minus 23 halves x to the third over 3 factorial. And you can simplify it if you want, but you don't need to. You can leave that just the way it is. Next, write the first 3 non-zero terms of e to the x. So that's 1 plus x squared over 2 factorial. And then they want you to use that and f of x, which, you know, is this, to find e to the x f of x. So that's, you have to FOIL that. You have to multiply those together. You do have to FOIL. So what I did is I took all the terms for second degree. So my e to the x, I did 1 and x and 1/2 x squared. So that's this term. And then here I did 3 negative 2x 3/2 x squared. And I got 3 times 1 is 3, 3 times x is 3x, and then 3/2 x squared, negative 2x squared, too big, 3x squared, sorry, 3/2 x squared, and then don't use it. Okay, so I ended up getting the e to the x f of x is 3 plus x. 3/2 and 3/2 makes 6/2. 6/2 is 3. So we have 3x squared minus 2x squared is plus x squared. And so that's what I got for part B. Part C, you had to be real careful because the notation was pretty funky on that one. And so I said, okay, h of x is 0 to x f of t dt. They said to use the Taylor polynomial found in part A. And so what I did is I went back and I wrote that, and I wrote it in terms of t. So I had 3 minus 2t plus 3/2 t squared minus 23 over 48 t to the third. So that's what h of x is. And then if you want h of 1, you're just doing the integral from 0 to 1 of that. Oh, it wasn't 23 over 48. I was copying my work from the wrong spot. 12. My bad. Okay. So if I go ahead and find the antiderivative of each of those, I've got 3t minus t squared plus 3t to the third. Is that right? Minus 23 over 48 t to the fourth from 0 to 1. I thought about bringing the 2 to the front, not bringing a 3 to the front. Okay, so that was, it's like that felt wrong. Multiply a 3 to the front, you get 1/2. Okay. All right, so I've got 3 times 1 minus 1 squared plus 1/2 times 1 cubed minus 23 over 48 times 1 to the 4th. And then, so that's all of the ones, and then you're subtracting off 0 if you plug that in. And you can leave this the way that it is, or you can do some simplifying. So you got 5/2 minus 23 over 48. Get your common denominator. So 5 times 20 is 100. 5 times 4 is 120. So you've got 120 minus 23, 97 over 48. All right, part D. So they want you to approximate h of 1 using the alternating